Let's think a little deeper on the concept of architecture. We are starting to move our code into different places in this project to architect our project. We've looked at some reasons why we might want to move code into a view model. We understand the view model is kind of baked into Android these days. But let's understand now in more detail why we're doing this. Before we understand architecture, it's worth understanding what is clean code and why does it matter. I've used the term clean lots of times in this course, cleaning up these files, cleaning up those functions. When we talk about clean in terms of code, we're usually saying things like code that's easy to read, short, simple functions, code that's easy to maintain. If you need to change it, or if you are debugging a problem, it's easy to find where things have gone wrong or where things might need changing. Scalable, so as the app starts to grow, by keeping our code clean and tidy, things are still easy to understand. To help hammer home the idea of what clean code is and why it matters, let me first show you something that isn't clean code. I was able to search into my archives and find some of the very first Android code that I ever produced when I made my first ever Android project many years ago, and it looked a little bit like this. Now, this is just main activity, and I'm not actually able to fit all of it on the screen. I have the first 100 or so lines on the left, and then going all the way up to line about 370 on the right. It's in Java. I wasn't working in Kotlin at this point in my career, and some of the things you might notice are a ton of class properties to the left. Lots of things that this class, the main activity, depends on. It depends on all those properties being there, so you could argue it has a lot of dependencies. Quite a lot of things going on in the onCreate function alone, and then you can see things like setting up the data store, setting up the database directly. Pretty much all of the code is just dumped into the main activity. The functions are difficult to read, and all of those properties made debugging this very difficult, as when a problem occurred, all of those properties at the top, they could be in any number of different states, and things were very difficult to maintain, very difficult to make changes to, and probably quite difficult for another engineer to come into this and look at this code. So this would not be clean code. So then what might clean code look like? I'd like to think that in the past few videos we've started to make our code clean and tidy, thinking in small functions, putting things in the right kind of place, but let's have a look at a more sophisticated example. Just for fun, I'm going to show you a sneak preview of Jetpack Compose, because Jetpack Compose can lead to some very pretty and clean looking code. You can imagine in an app we have a user profile screen, so we could write a little bit of code to represent the user profile screen. We might have a button where we would load the profile, and then we might have our screen either be in a loading, a success, or an error state. And if you were to look at this very simple 8-line function, reading things should be pretty straightforward. When we are in a loading state, show a circular progress indicator. In the success state, show the user profile and give it the data. And then if we're in an error state, show an error message, giving it the error message that we want to display. So even though we don't know Jetpack Compose yet, this is clean code. It's easy to read, easy to understand. If things were to go wrong, it would be pretty quick and simple to get to where the problem occurs, as there's not much going on here. This might depend on a user profile view model, which might look a bit like this. We might have one function to load the profile. We might launch some view model scope, the concept we've already covered. We might start off loading, and then we might try to load the user profile and return success if it was successful, or if something goes wrong, we could return an error with a custom message. And so reading this code is fairly easy. Not much going on here. Short, simple functions, a small class. This would be easy to maintain, easy to debug. And a good architecture can help us write code like this. Often when we think about architectures, you'll hear the phrase separation of concerns. If you think back to my old main activity from when I was first starting out, nothing was separated there. Everything was dumped inside main activity, database logic, setting up all the views, holding on to lots and lots of properties. Well, when we architect things, we think about moving things to different locations. And indeed, we've already been doing this by introducing our view model. We have the pure UI code in the fragments and activities, and then we have some of the non-UI code, where we get the data ready for the activity. Well, we have that in a view model. We're starting to separate the concerns. The view model shouldn't be concerned about the actual user interface. The actual user interface, the activities and fragments, shouldn't really be concerned with where the data comes from. That kind of thing. And so, to separate these concerns, and to start to build up our architecture, we think in layers. Each core part of the app is a layer, and then as we request things, we go down through the layers, and then when those requests are processed, we go back up through the layers, like a stack. And a very common one from the official Android documentation is this picture of the layers of architecture. So you might have the UI layer. In this case, the UI layer would be the activity, fragment, or composable, the actual screen, in combination with the view model. Those two things work together to form the UI layer. We could ignore this optional domain layer, but then the view model, that's the last point of the UI layer, that might then interact with a data layer. And you can see there in the data layer, that's made up of a repository. So the UI layer, via the view model, will request something from a repository. But it doesn't stop there. The repository will then pass on that request to a specific data source. And we'll be seeing this in the very next tutorial. But you have to imagine that an app can get its data from multiple places. It could get the data from a local in-app database stored on the phone. It could also get the data from the World Wide Web, and so it might store data in the cloud. These would be different types of data source. But if you introduce a repository, which the UI layer requests from, well then, the UI layer doesn't care where it comes from. And the repository could have a local database, it could have a remote cloud database, it could even have both. So it pulls in your data, and then it could save it locally as like a cache. So then if you were to go through a tunnel or lose network connection, the app would save locally the things that it got from the World Wide Web. That's a very common pattern. And so by having the repository layer, you allow the flexibility to change or combine or use multiple data sources, and it doesn't affect the rest of your app. So UI layer, an optional domain layer that we won't be looking at just now, the data layer, and the data layer being made up of a repository, and the repository then calling a data source. So you can see we have these different layers, and having these places where we can separate the concerns, put things where they belong, helps to clean up our code. So one layer, one class, one file isn't having to do too much, and it's a very good way to think about our code. So we've talked about clean code, we've talked about separating the concerns and thinking in layers. This all forms part of an architecture. And what is it that an architecture can give us? Well, three main things in my opinion. It can give your code base structure. If you have a defined architecture with defined layers, then you have a defined place for different things to go. It helps make the decision-making process easier to know that UI code should go in the UI layer, that data code should go in the repository, that kind of thing. It defines where things go and how they interact. It separates the concerns, so each layer has a clear job. It's much, much easier to know where to put things when that's already been pre-decided in the architecture structure. It gives our code clarity. You end up with smaller, focused classes, which makes code easier to read. Rather than doing the UI, the request, the database operation all in one place, you end up with small functions that call other small functions. Much, much easier to digest. And you have clear responsibilities, which make the code easier to navigate and understand. You need to request a new type of data, like the user's profile information, put it in the repository. After getting the user's tasks you want to sort them, do the sorting in the view model. When you choose an architecture and stick to it, it becomes clear where things are supposed to go, and you know what a view model should do, and you know what a repository should do. Things are very clear. And then finally, it gives you flexibility. It's much easier to change without breaking everything. If you have a repository layer, which might depend on one or more data sources, well, if you start off with a database but decide later you want to move things to the cloud, like using Firebase or some kind of web database, if the app is only ever interacting with the repository, then you just simply need to swap out the data source in the repository. You don't have to change any of your app code. Nothing breaks at all. And that flexibility is incredibly powerful, to be able to change the data source and for everything else in the app to work exactly as it did before. You can then adapt and scale as the app grows, meaning when you have more and more data requests, you might introduce a new repository. If you start off as a local database but want to move to the cloud, again, as your app and your project grows, you've made it very easy to do that by separating the concerns, having clear responsibilities. Changing one part of the app doesn't break the rest of it. That's some of the big things that an architecture can give us. MVC, MVP, MVVM, MVI, these are all common architectures used in Android development. MVC stands for Model View Controller, and that's kind of the default architecture. Your models are your data classes or your plain Java objects like a task or a to-do, something like that. The view would be the XML, and then the controller would be just your activities and fragments. That's kind of what my first example was, everything dumped in the activity, MVC. So later on people decided maybe we should separate things a bit, so MVP was Model View Presenter. People were starting to put some of the business logic that didn't touch the UI in a thing called a presenter. That was an unofficial way of starting to separate some of the code from the activities and fragments, and then eventually Android became opinionated and decided a view model was the better way to do it, so MVVM, Model View View Model, was like the natural evolution of the Model View Presenter. The view model acting a bit like a presenter, except the view model is very much aware of the life cycle. It works very nicely with activities and fragments like we've seen. And then some engineers took things a bit further and expanded the Model View View Model pattern with things like Model View Intent, which is just a more sophisticated way of using the view model. For our intents and purposes and for the rest of the section, we will be looking at MVVM, currently the most common architecture in Android, and indeed we're already well on our way towards it by introducing the view model. And so, let's add a data layer to our architecture by introducing an app repository. And in doing this, we will complete the common MVVM architecture. We now have the full MVVM architecture now that we have our data layer, courtesy of our task repository. However, in the previous tutorial, we didn't run the app, so let's go ahead now and run it and make sure everything is working as expected in our new complete MVVM architecture. So, running the app. And the first thing to note is that we can actually see our tasks. So our getTasks function that happens in the tasks view model, the fetchTasks function, which happens in the task fragment, well, this flow is working nicely. View model fetch tasks, repository get tasks, and then our data source get all tasks. So we already know that is working. The next thing we could try is the create task button, which is in our main view model, where we call repository.createTask. So we'll press the plus button, we'll do my new task made in a repository, and then save. And that appears to be working fine. How about the other functions to update a task and delete a task? Well, we can test whether the task update works by marking one complete. So I will click some task. Now that's a bit strange. The checkbox did change, but normally our task would be moved to the bottom and have the text style as strike through. If I were to back out of the app and then go back into it, the task is at the bottom, but whenever I update a task in the app, it doesn't appear to be working. So something is not happening to refresh the tasks when we update them. And if I go to the tasks fragment, well, we update the task, but we don't do anything to then fetch the tasks or to refresh them. So we should probably go back to the task fragment and think about what we can do here. Well, one thing we can actually do is to call fetch tasks again after performing the update and delete task. So we'll do this for now. It's not ideal. It would be good if this update happened automatically, but for now we'll just call fetch tasks again and see what happens. So I will run the app. I can see those tasks are now crossed out. So if I cross out the top one, okay, that appears to have worked. But if I do another one, okay, that one worked. I've tried to do another one, but it looks like that didn't work. I pressed again, now it works. And what I'm finding as I'm clicking these things is that sometimes it updates, and sometimes I've got to click them twice. So there's definitely something a little bit up with our method of refreshing the tasks. So good news, our repository does work. Our architecture is nice and clean, and we can create, read, update, and delete tasks. Sometimes it takes 2 clicks though. But we do have a bug with the way that we refresh things. Refreshing is temperamental at best. Sometimes it works, sometimes it needs a couple of clicks to work. And to fully understand why this is happening, we will need to do some debugging and learn something about the way coroutines and threads work. So let's debug this strange, slightly buggy. In the last tutorial, we discovered that our new MVVM architecture with view model and repository is working, which these operations had completed. So a first attempt we made to try and fix this back in the tasks fragment is after we call the update task and delete task function, we call fetch all task clicks. It generally seems to be a bit temperamental. I'll command click into this function, and I will do a log before where we update the task. So we'll do log.d for debug, and I'll give it a tag to make filtering the logs easier. So I'll simply call this tag vin. You can do whatever tag you want. You can even do cheese. Okay, we'll do vin though for me. And then we'll say about to update the task, ... Because we're just before the repository.update task function. This is the suspend function. This is the thing that can take some time. So we'll mention we're about to update the task, and then I'll copy that log, and afterwards I'll change the message to task updated. But then we will also, back in tasks fragment, after we fetch the tasks, do a log here. So log.d tag vin, and we'll say tasks fetched. So 3 logs. We find out when we're about to update the task, then we have our suspend function, which could take some time, and then we log here once the task is updated. So the task will only be updated in the database after this line completes. I'll just do an auto format to get rid of those spaces. And then in the tasks fragment, we do a log to say when the tasks have been fetched. So if we run this now, open up our logcat and filter by the vin tag, or whatever tag you have, we should see a bit clearer what's going on and what the problem really is. So running the app again. Okay, and I have my emulator on the right. I have my bottom pane a little bit smaller so I can still see my emulator. And I'm going to change it from run, which is the pane that normally pops up when you run the app, and I'm going to change it to logcat. And to trim down some of the noise, because this will have all of our tasks, you can see tasks fetched there, I'm instead going to filter by adding after package : mine, a space, and then tag : and then the name of your tag. In my case, it's VIN, like that. So I can see the tasks fetched log came back fine. But what happens now if I update a task? So I will click some task. Well, about to update the task, but then tasks fetched happened first, and then task updated happened second. Now that's not what we want. We want the task to fully update and then to fetch the tasks. Let's try it again. I'll try and uncheck add a new task. About to update the task, tasks fetched, task updated. I'll try and click it a few times to make it sometimes work. So uncheck and uncheck. I'll just actually delete some of these logs to clear out the noise a bit. So do some stuff. Okay, that one worked. About to update the task, task updated, tasks fetched. So that time it worked. I'll try it again. That one worked. I'll try it again. That one didn't work. Okay, so sometimes the update happens, then it fetches. Sometimes it fetches the new tasks, and then the task is updated. So we've discovered the problem. It's not always doing it in the order we want it to. And why not? Clicking in tasks fragment. Update task launches a new coroutine. A coroutine is a bit like a thread. So we're now in a different coroutine. This code can take a long time. There's actually no guarantees as to how long the update task might take. This is running in the background. But heading back to tasks fragment, after we call update task, which launches that coroutine, we immediately call fetch all tasks, which launches its own coroutine. The fetch tasks function, well, that's a suspend function. This get tasks function in the repository, well, that can take an unspecified amount of time. Maybe it would be shorter to get all tasks than to update a task. Maybe sometimes it'll be longer. There's no guarantee as to which one of these is going to take longer, but because they're both happening in separate coroutines, either one is allowed to complete first. And indeed, that's exactly what's happening. Sometimes the viewModel scope update task finishes first, sometimes this suspend function completes, and sometimes the lifecycle scope fetch tasks function, this suspend function, sometimes that one completes first. And that is no good. And so after all of our hard work making clean code and having a nice architecture, we're kind of back into this problem of needing to do some kind of clunky mechanism, some kind of callback to say when the tasks have been updated successfully. So we could do something really messy like this. We could do an on task completed callback, just a bit of code, a function that will fire when things have successfully completed. So we could remove our logs now and do on task completed, and then instead this becomes a lambda, and we can call fetch all tasks in here. So now this fetch all tasks function will only happen once the task has updated. And indeed, if I run this now, this should and will work every time. You can see it's back to working perfectly. Okay, so by only firing this callback function, a concept that we still haven't really covered, but by firing it after update task inside this coroutine, so this is definitely after the task has been updated, well, then we are able to fetch all tasks in the correct order, and this works every time. However, we're back to some weird looking code, callback functions, still having to manually call fetch all tasks all the time. And it's not ideal. We're trying to work towards clean code in our new architecture. If I just close down the run pane and the logcat now, what would be ideal would be some kind of mechanism where we can observe the tasks in the database, where we can listen for any changes, and whenever there are any changes in the database, automatically update all tasks. After all, at the moment, the fetch tasks just returns a normal list of tasks. The repository just returns a normal list of tasks. How can we listen out for changes? How can we continuously receive updates whenever there's something new? And fortunately for us, in both the Room database and the Kotlin language, there is just the thing. It's a concept called flow, Kotlin flow, a mechanism where we can receive updates whenever things change. But before we look at this flow type in Kotlin, and before we look at how the Room library works with Kotlin flow, to fully understand what flow is in Kotlin, we first need to understand the concept of the observer design pattern. So in the next tutorial, we'll do a deep dive into the very concept of observing things that can update over time in the observer design pattern.